Good evening, everyone. I request Gurvinder sir to conduct the session.
Hello, good evening, sir. Good evening, everyone. Hello.
Good evening,
I hope I
sir.
am audible.
Yes, sir, you are
Good
audible, sir.
evening, sir.
Hi, hi. Hello, everyone. Hello, good evening. So yesterday I had given two questions. Was anyone able to solve any of them, or you have tried at least?
So I've tried sir one question.
Which one? First one, second
Eh,
one.
First one, sir.
Okay, first one. Okay. So where did you reach? Were you able to reach somewhere?
So I couldn't understand a question because here A1 equal to B1, no, sir.
A1 is equal to B1. Yeah. Uh, no
I
worries.
had
I have opened the same page as yesterday. So, okay, so we'll be solving the questions today. So, I hope everyone has given it a try. I hope just everyone has given a try to it.
sir.
Or, no, I'm asking, you have given a try to the
Yes, sir.
questions.
Yes, sir, I have tried, sir.
Okay. So, you weren't able to do it. Okay, no worries. So, which one should we do first? This one or the second one? Which one do you want to do first?
This one.
This one you want to do first? This
Yes,
one?
sir. Yes, sir.
Okay, great. Okay, no worries. So A1, A2, A3 are positive integers in AP. Their common difference is 2. Okay. B1, B2, B3, all of these are positive integers in GP and their common ratio is 2. Okay. A1 is equal to B1 is equal to C. And it is asking me find number of possible values of C for which 2 times A1 plus A2 plus AN is equal to B1 plus B2 till Bn. Okay, fine. So no worries, I'll be doing it. Just a minute. Right, so I will solving I will be solving it here. So just a minute. So yeah, so see what is happening is hi, hello everyone. So see what is happening is I have A1, A2, A3 like that. Okay, okay, they are in AP and their common difference is 2, right? Then I have B1, B2 till AN and this is till BN. Okay, and this is in GP, common ratio is 2, and the first term of both is same. Okay, it is same and it is equal to some value C. Okay, this is the one that is given to me, and they have told me that 2 times the sum of AP, the 2 times sum of AP. Can you tell me what will be the sum of AP n terms? Can anyone tell me? Can anyone tell me?
A1 plus A2.
अरे यार वो तो like
Okay.
what is the what is the sum, like what is the formula for sum n
Uh,
terms AP?
okay, sir. Sn equal to
It
n by 2 by A 2A plus n minus 1
n
into
by
B.
2 into yes
2A.
into 2a plus n minus 1 into d.
सॉरी सर मैं सोचा वो आप कैसे लिखते बोलो फॉर्मूला नहीं सोचा मैं.
Okay, no worries. I got it. But no issues. So no one was able to like get the answers. No one, not even a single one. Okay. Okay, no worries. So see, this is 2 times the sum of GP, 2 times sum of AP, right? 2 times the sum of AP. And tell me what is the sum of GP? Sum of GP formula?
A into 1 minus R to the power of n by 1 minus R, sir.
Right. So R is 2, right? R is 2 here.
Yes,
In
sir.
other words, I can write this thing as like I can write this thing as C into 2 raised to n minus 1 also, if you clearly observe, right?
Yes, sir.
Right. So basically what is happening is I will just open this expression up. So it is n into 2c plus 2n
2
minus 2, right? And this
Yes.
is c into 2 raised to n minus c, right?
Mm.
Now can you open this? So it is 2cn plus 2n square minus 2n is equal to c into 2 raised to n minus c, right?
Yes, sir.
So I will just take c one side and n one side. So it is 2n square minus 2n is equal to c into 2 raised to n minus 1 minus 2c. Oh, sorry. Minus 2n, right? In other words, my c is coming out to be 2n square minus 2n divided by 2 raised to n minus 2n minus 1. Fine. Everyone got till here?
Yeah, sir.
Anyone who has not arrived till here? Varshini, formula of GP, I'll just write it here in case if you don't know. So formula of GP is A into 1 minus R raised to n by 1 minus R. Fine. Sum of GP. N terms of GP. Okay. I taught it on Sunday. I had taught it on Sunday. Okay. So can
सर
anyone
एक बार बोलो सर
what?
तो n into 2c plus n 2n minus 2
It is basically it has told me that 2 times the sum of AP is equal to my sum of GP. Fine. So I have just applied the basic formula. So 2 times n by 2 into 2a plus n minus 1 into d is equal to a. So my a is c basically, right? A1 and b1 both are equal to c. So a into 1 minus r raised to n by 1 minus r. So my r is 2. So I have in place of r I have put 2. So it is c into 2 raised to n minus 1. After that, when I got this thing, so I substituted, like I tried to divide n on one side and c on one side. So I took out the terms, multiplied them, and took out c on one side and n on one side. So this is what I got. I got c is equal to 2n square minus 2n by 2 raised to n minus 2n minus 1, right? So now it is telling me, yeah,
सर आंसर यही है क्या सर?
no, like how can this be the answer? It is asking me, just go back to the question. What is it asking me? It is asking me what is the number of possible values of c. What are the
Yes.
number of possible values of c for which this condition is true and n is a positive integer? So see, one thing you know for sure. What do you know about c? What do you know about c? Can you tell
A
me
is
what do
equals
you
to
know
B
about
is equal
c?
to C.
Arey, I already know that. But what, like, do we already know that c has to be an integer, a positive
Yes.
integer,
Yes,
right?
sir.
C also has to be a positive integer
Yes, sir.
because a1, a2, an all are positive integers, b1, b2 till bn all are positive integers. So a1 and b1 both are equal to c. So c is obviously a positive integer, right? C is also a positive integer, and your n is greater than equal to 1. So can you tell me what value of n? What value of n will you put here?
1, sir.
What value of for what values of n?
1 to
For what
1.
values of n
It is
will you get c, a
Natural
positive
number.
integer?
Natural number, sir.
I know. See, you will be substituting different values of n, okay? First, you will check at n is equal to 1. Okay, so I will check at n is equal to 1 first. So can you tell me what will be my value of c? So it is 2
0,
into
sir.
1 square minus 2 into 1. So divided by
Sir,
r. So it will be 0.
sir.
So this case won't work. This case won't work, right? Because my c has to be a positive integer. C can't be 0. Fine? Fine? C can't be 0. So this case is not correct. Now I will check for n is equal to 2. Can you substitute n is equal to 2 for me? So it is 2 into 4
4
minus 2 into
2 into
2.
2
Right? By 2 raised to 2 minus 4 minus 1. Right? So how much is it? It is, I guess, a negative value.
8
Right?
by 8 by 4 by
minus 1 sir
4 by 3.
Minus
4 by?
4 by minus 1 sir
So it is minus 4. So this
minus
won't
4,
also work.
sir.
This will also not work, right? This
Yes,
won't
sir.
work. because I can't get a negative value. Same, I will try for n is equal to 3. Now try for n is equal to 3. So 2 into 9 minus 2,
Minus into 3.
2 into 3.
Three.
Whole
Nine.
divided by 2 raised to
So
3.
3, sir.
2 raised to
Minus
3 minus 6 minus 1. Fine.
Yeah, sir.
So it is 18 minus 6. 18 minus 6 is 12.
12.
12
By
divided by 8 minus 7, right?
12,
8
sir.
minus 7
Answer
is 1.
12, sir.
So it is 12.
12.
So this case works, right? This case will work. So I have
Yes.
a one case. So I have
So
one
can you
case.
take
Now I will
minus
try.
1?
No. I can't take n. It is given to me that n is also a positive integer. Again, go back to the question and read the last line of the question.
Okay.
N is also a positive integer. See, it is given to me. N is a positive integer. N can't be 0 also. It is given to me already that n is also a positive integer. Okay. So now try for n is equal to 4. Can anyone do it for me fast? Can you substitute n is equal to 4?
Yeah, sir.
Yeah. So can you substitute and tell me what is the value of C?
1 minute, sir. Sir,
Yeah. How much?
24 by 5, sir. 24 by
24 by
7, sir.
5.
Sorry.
So
7, sir. Sorry.
24 by 7. Okay.
Yes,
24
sir.
by 7. So it won't work,
Yes,
right?
sir.
It won't work
Yes,
because it
sir.
is not an integer. So it won't work. So fine. Can we go one step further? N is equal to 5. Can we go for n is equal to 5?
All, sir.
What?
2 into 25 minus 2 into 5 by
2 into 25 minus 2 into 5 divided by. Yeah.
5
Go ahead.
minus 2 into 5 minus 1. It will 50
40 by
Minus 10
10
minus
by
1.
40
How
by
much is it?
minus 10 minus 1.
50 minus 10. So it is 45. 40 divided by how much? 40
20.
divided by 40
21,
divided
sir.
by 21. So this will also not work, right?
Yes, sir.
Because
Sir.
it has to be. Now, can you tell for n is equal to 6? So you can observe clearly. You take any value now higher. You can like go higher. What will happen? My denominator will grow larger than my numerator. You can just try. Try n is equal to 6 now. If you try, what will happen if you put n is equal to 6? So it is 2 into 36 minus 6 divided by 2 raised to 6 minus 2n minus 1, right? So it is 60 divided by, what is 2 raised to 6? 64, right? 64 minus 13. So it is
51.
51,
Sir,
right? So this will also not work. Yeah.
we need
What
nothing,
happened?
nothing is like this.
Okay. Okay. Okay.
Okay, sir.
So you can just try. If you take any value now higher than 6, what will happen? Your denominator will grow greater than your numerator. Okay.
So,
Your denominator, yeah, you can try with n is equal to 7 if you wish to. I can do it for you. So you can just try. So it is 2 into 49 minus 7 divided by 2 raised to 7 minus 14 minus 1, right? So 2 into 42. So it is 84
84.
divided by 2 raised to 7 is how much? What is 2 raised to 7?
One.
It is 128, right? So
28.
128 minus 50.
128, sir.
So it is 113, right? So now
Yes,
your denominator has grown higher. Now your denominator has grown higher than your numerator. So your numerator divided by denominator cannot be a positive integer because your denominator has grown higher. And now, like, see, just it is actually a basic. See, what is happening is your numerator is a quadratic equation. Okay, your numerator is a quadratic equation, and your denominator has a power term, exponent term, right? So what will happen? Your denominator will grow faster compared to your numerator, right? Because it is power, like it is getting multiplied. 2 raised to n it is. And it is 2n square. So you can easily infer that 2 raised to n will grow very faster compared to 2n square, right? You know this, right?
Yes, sir.
Even like it is just basic, like you can just think of it. So you can try for any value. Now, any value greater than 6. So now what has happened is your denominator has grown higher. So you try any value greater than n is greater than 7. If you try for any value, your denominator will be higher. So no way you can get a solution. So there was only one solution possible with n is equal to 3. So now, has everyone got it? What is the final answer to this?
Yes, sir. Yes,
Sir.
sir.
So there is only one solution possible, right? So the answer to this question is 1, because only one solution is possible. And they have asked me, what is the number of possible values of C? So there is only one possible value of C. Fine. There is only one possible value of C where you can get it as a positive integer. In no other case, no other value of n you can substitute in order to get your C as a positive integer. You can try, you can substitute as many value as you want, but no value other than n is equal to 3 will give you C as a positive integer. Fine. So the answer is 1. Everyone got it?
Yes, sir.
Really?
Yes, sir.
Okay.
Yes, sir.
Okay. Great. So कहाँ चला गया? Yeah. Fine. So see, actually, in this question, you were just required. Just look back at the answer. Okay, I'll just show this answer back to you. So what is happening here, if you just clearly observe, the first values are given to you as integers, okay? After that, you have substituted and got your C in terms of n. After that, you are just trying to substitute different values of n and trying to check if your C is coming out to be an integer or not. And after one range, after n is equal to 6, you will begin to observe that your denominator has grown even higher than your numerator. So there is no chance that you can get a solution, right? Because after that, no matter what higher values you take, your denominator will definitely grow higher. So that is how, that is what was the basic catch of the question. Now coming to this one. So has anyone tried it? Anyone who has tried it?
No, sir.
Achha, not tried only. Okay. So see, what is happening is log base E B1. Okay, it is called ln also. So ln B1, ln B2, ln B3 till ln B101 are in AP, and the common difference is ln2. So can you tell me what do we infer from this thing? Yesterday also I had given you a same question, if you remember. Log B1, log B2, log B3 are in AP and the common difference is log 2. So what did you infer from this thing? What was your inference?
B3 and so on are in GP.
GP and their common ratio is 2,
2. Yes, sir.
right? So
Yes.
everyone had got this, right? Everyone had got this yesterday, how this thing came? Yesterday there
Yeah, sir.
was something I taught you. It was a concept. How you could convert your AP to GP and your GP to AP, right? What was the trick? Anyone remembers or not? How did you convert your AP to GP? I guess no one remembers. No one has revised.
Inverse of exponent is
Correct. So what happens when you, like, you have a sequence A1, A2, A3, A4, A5. So when you raise it to any base, okay, so this is your base X. So it is X raised to A1, X raised to A2, X raised to A3. So it becomes a GP. It becomes a geometric progression.
Yes, sir.
Fine. And similarly, when you take logarithm of a GP, when you take logarithm of a GP, it becomes, what does it become?
G. AP, sir.
AP, sir.
Correct. When you take logarithm of GP, it becomes an AP, because like exponentiation, the inverse of exponentiation is logarithm, and its common difference becomes log of R. So that is what is happening here. Log B1, log B2, log B3, log B4, all of them are in AP and their common difference is log 2. So in other words, B1, B2, B3, they are in GP and their common ratio is 2. So now just think of it like this. I'll just solve it here. See, what is happening is B1, B2, B3 till B101, they are in GP and their common ratio is 2.
Yes,
Fine.
sir.
And what is happening? A1, A2, A3, A1, A2, A3 till A101, they are in AP and their common difference is 2. Fine.
Yes, sir.
Yes,
Fine.
sir.
So one more thing is given to you. What? A1 is equal to B1. Your A1 and B1 first terms are same and your 51 terms, the 51th terms are also same. How do you use this thing? Like how do you use this information? Your A51 is equal to your B51. How do you use your information? How do you use this information? Oh, I am really sorry. Just a second. Your common difference is 2 is not given to you. Sorry. Common difference is not given to you in the question. So since it is not given to you, so now you have easily inferred. What do you use from this information? Your 51th term of your GP is equal to your 51th term of your AP. So how can you use this information? Okay, so first of all, can you tell me what is the 51st term of the AP? Can anyone tell me what is the
A plus 50 into D, sir.
correct? A plus 50D, correct. And what is the 51st term of the GP?
GP, okay, sir, GP.
GP, what is the nth term of GP formula? Nth
A
term of
into
GP.
A
A
into
into R raised to
minus
N,
1.
right?
50.
Yes,
Yeah.
sir.
So it is basically B1 into 2 raised to 50, right?
Yes,
Because
sir.
common ratio is 2, right?
Yes, sir.
And both of these are equal, right? Both of these are equal. So basically A1 plus 50D is equal to B1 2 raised to 50. And one more thing is given to you. What? That your A1 and B1 are equal. Your A1 and B1 are equal. So, so now you can get your value of D, right? Arey, A1 and B1 are equal, Baba. So it is
Yeah, sir.
A1 into 2 raised to 50. Fine. Because B1 and A1 can be replaced now. So can you tell me what is your value of D now? Your D is equal to 1 by 50 into A 2 raised to 50 minus 1. Fine. Has everyone got this?
Which formula do you use this, sir?
Like I'm just taking out this side. That's sorry. I'll just do it again. No worries. So just take it out this side. See, 50D is equal to, so just take it out this side. So it is A1 2 raised to 50 minus A1. Fine. This thing can be written as A1 into 2 raised to 50 minus 1. Fine. This is equal to 50D. So your common difference is basically A1 by 50 into 2 raised to 50 minus 1. Fine. Has everyone got this?
Yes, sir.
Yes, sir.
Everyone got your common difference, right? So now
Yes, sir.
you have your common difference. So now what is what is the need to worry when you have your common difference? See, you have your first term of both AP and GP. You have both first terms of your AP and GP also, right? And you know its common difference also. And you know the common ratio also. So basically you know everything about both AP and GP. Fine? You know everything now. Is there any information that you don't know? See, I'll just tell you. I'll just write it here. You have an AP, you have a GP. Okay. For AP, you need two terms. You need the first term and you need the common difference. For GP, you need the first term and you need the common ratio. Okay. You know the first terms of both. You know the common difference, you have derived it, and the common ratio you already know it was equal to 2. It was given to you as 2. So is there anything left now that you don't know? No, like you already know everything. So now it is just asking you to compare values of A101, B101, and the sum of first 51 terms of both AP and GP. Can you do it now? Can you compare? Can you find out first of all? Okay, so first of all, we will find out. Can anyone tell me what will be the 101th term of the AP?
A plus
What will be
100D, sir.
A plus 100D, correct. Right? A1 plus 100D. And what will be B101?
A into R to the power of 100.
Right. A1 into 2 to the power of 100. Fine?
Yeah, sir.
Yes, sir.
Right. So can you substitute D here? Can you substitute D here?
Okay, sir.
You can do it, right?
Yes, sir.
Right? So you can easily do it. And now can you tell me what is T? What is S? So we will do S first. So S is basically A1 plus A2 plus so on till A51. Can you tell me what will be its expression? So it is basically sum of first 51 terms of the AP. Can you tell me what will be the sum of first 51 terms of AP? No one. What is the formula for sum of first 10 terms of AP?
N by 2 into 2A plus N minus 1 into D, sir.
So what will you substitute in place of N?
51.
51, sir.
Yes. So like, why is it taking so much? Okay. So it is 51 by 2 into 2A1 plus 50D.
Yes, sir.
Fine.
Yes, sir.
And your T is basically B1 plus B2 plus so on till Bn, right?
Yes, sir.
It is a sum of n first 51 terms of it has specifically told me to take only till 51. It is sum of first 51 terms of GP. So can you tell me what is the sum of first 51 terms of GP?
A1 into
Right, A1 into
1 minus
hmm,
2 raised to 51, sir,
hmm,
by
hmm,
1 minus 2.
hmm. So 1 minus 2 is basically minus 1. So I will invert it. So this thing can be written as A1 into 2 raised to 51 minus 1. Right?
Yes, sir. Yes, sir.
Okay. So now what it is, see, now you know the value of D also, right? You have found out the value of D. Fine. You have found out the value of D, right?
Yeah, sir.
So anyone who has any confusion in how we found out the value of D, please ask. Otherwise, I am assuming that you were able to calculate the value of D successfully. Anyone who has any issue about how we calculated the value of D? Bhavna, Varshini, Shiva, Bhaskar, Ashrita,
No, sir. Understood.
Gayatri,
Understood.
No,
Vignesh.
sir. Understood, sir.
Understood.
Understood.
No, sir.
Okay, no worries. So, okay, great. So see, what is happening is like we have the first term same, okay, and the 51st term is same. So we just compare the 51st term of both AP and GP and equate them. When I equate them, so I get this thing. 50D is equal to A1 into 2 raised to 50 minus 1. So I have got the value of common difference also of AP. I have the value. So now I'll just give this to you as homework. Okay, so now you have everything. You have the value of D also, right? I have found out the value of D for you. So now it is just your, like, you just have to do this much, that find the value of A101, find value of B101. Okay, first find this value, then find this value. Okay, then compare that which one is greater. Is A101 greater or is B101 greater? Fine. Then find the value of S and the value of T you already have. Okay, and then compare which one is greater, S or T, which one is greater. So all you need to do is you have the value of D, just substitute inside it. Okay. So only this part is your homework, and tomorrow we will be discussing its answer. Fine. Anyone who like thinks they won't be able to do it due to any reason? See, I have found out the value of D for you. Fine. I have found out the value of D for you. A1 you already have here. So indirectly B101 is also found out. So all you need to do is find the value of A101 and S and compare it to value of B101 and T respectively. Fine. Will you be able to do it?
Yes, sir.
Fine. This much, I guess, you will be able to do, right? I am actually not getting that much confidence from your voice. So should I do it? Do you want to do?
Will do.
Vignesh, you can
No, sir,
do?
we will do it.
Fine. Like, see, it is given to you A1 plus 100D, and I have given you the value of D also. So you just need to substitute your value of D here. Same thing, S is equal to 2A1 plus 50D. So just substitute your value of D here. So I don't
What?
think it should be very difficult. Just you have to substitute only the value of D. Fine.
One substitute,
Okay,
sir.
so yeah, okay. And then just compare it and come with the answer tomorrow. Fine. If
Okay,
not,
sir.
we'll be doing it tomorrow. Okay.
Sir, one
Okay,
show.
fine. Yeah, I will anyway send the PDF only. Yeah, you can see this. Anyone who has not understood how we derived the common difference here? Anyone? Gayatri, Divya, Bhavna, Ayushi, Shiva, Varshini, Bhaskar,
No, sir.
Navneet, Lakshini. Okay, so
Understood.
you have understood, right? Okay, great.
Yes, sir.
Yes, sir.
Okay, great. But sometimes like you don't give response in the way I expect, so fine. So today we'll be just moving ahead and discussing about the sigma operator that we had earlier discussed also. So just related to that, I'll just give you one or two more properties related to that. So before that, sigma, okay, I is equal to 1 to n. Can you tell what does this thing mean to you? What does this
A1 plus
thing?
A2.
Sum of natural
Is it
number.
A1 plus A2? Are you sure?
Sum of natural
Yes,
number.
natural numbers, correct. Right? See, just think this thing as a function, okay? Think this thing as a function, okay? So what is happening is below defined, it is like below whatever is defined, it is a function. Okay, so fine. Instead of n, I'll just give you a number. So it is 1, 2, let me take it 100. So basically what is happening is you have defined a number below, okay? You have defined a number that is your variable. So just substitute this variable inside your function and then keep on increasing it till your upper limit comes. So your variable is being defined as I. So first you substitute I as 1. Okay. Then you substitute I. So you increase the value. You increase the value till
100.
your upper bound comes, right? So this is what it means. Right? So now can you tell me if I do it something like I is equal to 1, I till n. So what is happening? What is happening here? So earlier your limit was till 100. So now your upper bound is, how much is your upper bound? Now it is n. Now it is a variable n,
N.
right?
Yes, sir.
Now it is a variable n. Fine?
Yes,
Yes.
sir.
Correct?
Yes, sir.
So like now you get the point, right? And just one more thing to make clear. Now let us assume something like this. I is equal to 1 to 100 n. Now can you tell me what will happen now?
N plus 1, n plus n plus n plus so on. So.
Correct. It will be n plus n plus n plus so on. How many times?
100 times.
N
Correct.
times. Oh,
100.
sorry, 100 times.
No, it will be 100 times because
Yeah,
I
sir.
have taken from 1 to 100. Fine.
Yes,
Now you
sir.
understand why it is n. Yeah. Any doubt?
No, sir.
Okay, great. So see, what is happening is your function inside. Okay. Whatever is inside your sigma, is actually not depending, like it is not giving a care about the variable, because your variable is not present basically inside this thing, right? It is not present inside. Fine. Do you get it?
Yes, sir.
Okay, great. So just similar problem. So I have sigma I is equal to 1 to n. Now can you tell me what will happen?
Same, same,
So
n plus so on to n.
Until
yeah, how many times? N
Times.
times.
N times.
Correct. So it is basically n squared, right? And this is basically 100n. Fine. Do you get it right? Like
Yes,
n,
sir.
if I am adding n 100 times, so it is basically 100n. And if I'm adding n times, so it is basically n multiplied by n, so it is n squared, right?
yes, sir.
Fine. And what about this? It is 100 into 101 by 2, right? And this thing is n into n plus 1 by 2, right?
Yes, sir.
Sum of first 10 natural numbers. Fine. So now you have clearly understood your sigma operator, right? These are the only important cases in which you need to understand how your sigma operator behaves. And it is, okay, so just giving you one more example. So can you tell me now sigma I is equal to 0 to n, okay? I is equal to 0 to, okay, let me take some numerical value, 99. Fine. Or, okay, I will take 100 only, no worries.
1,000, sir. 1,000.
Okay, and it is 2, okay, no worries, I'll take 1000. So it is 2 raised to I. So now can you tell me which thing am I basically asking you? Like what am I asking to sum? What will be the summation? Tell me.
1.
What?
2.
1
So it is
plus
2 raised to 0 plus 2 raised to 1 plus 2 square
Two
plus so on till 2 raised to 1000, right?
Yes,
yes,
sir.
Right? This is what I'm asking, right?
Yes, sir.
Okay, great. Same
Yes,
thing if
sir.
I give you in this way. Sigma I is equal to 0 to some value, let me assume n. Fine. A r raised to power I. So what am I basically asking you? What
AR
is this
raised
thing?
to
So it is
0
A
plus AR raised to 1,
1 plus
AR.
AR raised to square AR raised to cube
right?
plus so on AR raised to n.
Fine, this only, na?
Yes, sir.
Okay,
yes,
great. Okay, great. So yeah, that is correct. So in other words, if you just, so I'll just give you one small example there in the other case also. So if you look, I'm giving you I is equal to 0 to n, okay? Or, okay, I is equal to 0 to n. And now I'm giving you n times I. So what is this thing equal to? Can you tell me now? It is ni.
0 plus
0 plus
Correct.
plus 1 n
n.
plus 2n plus 3n plus so
2
on.
plus 3 and
Till n squared, right?
Enter.
Yes, sir.
Right?
Yes,
yes,
sir.
sir.
Okay, so I'll just start my
N.
term from 1. Okay, I'll start from 1, no worries. Right? So this is what I'm asking, right? Right? So this thing, if I,
Yes,
can I take out
yes.
n? Can I take out n from here? So it is 1 plus 2 plus 3, so on till n, right?
Yes, sir. Yes, sir. Yes.
Right? So in other words, this can also be written as n sigma I is equal to 1 to n I, right?
Yes, sir.
Your sigma ni from I is equal to 1 to n can also be written like this, right? It can be written, right? Because it is n times multiplied by sigma, right?
Sir, yes, sir.
Sir.
Yeah. The same thing, if you if you clearly observe here, if you clearly observe that thing here, so it can be written as a times sigma I is equal to 0 to n r raised to I, right?
Yes,
You
sir.
can take r raised to I common. You can take that, right? Because you can take a common out from each of these. Fine.
Yes, sir.
Yes, sir.
Okay, great. So basically, in other words, like it was just a small property that I had to teach you. So there is a small property of this sigma operator, and like it was very intuitive also. If you could have just like you could have just thought of itself also. See what is happening is I have sigma, okay, of some function f of I, okay, and it is getting multiplied by some constant c. Okay, I'll just write it as constant c. So it is c times f of I. Okay, c times f of I, and your I is running from limit L1 to limit L2. So what will happen? Your c will come outside, and it will be I is equal to L1 to L2 f of I. Fine. Your basically your constant c is a constant. So basically your constant comes outside, like outside. So it gets multiplied. Fine. Everyone understood this? Everyone understood this?
Yes, sir.
Yeah. See, what is happening is sigma ni, right? So basically, what is happening is you have a function of I that you are adding again and again and again, and it is getting multiplied by a constant c. It is getting multiplied. So I'll just give you one more example here. So see, it is sigma I is equal to 1 to 100 times 3i. Fine, 3i. So what am I basically asking you? So is it 3 plus 6
3 plus.
plus so on till 300, right?
Yeah, sir.
So basically it is 3 times 1 plus 2 plus 3 so on till 100, right?
Yeah, sir.
So
Yes,
this thing
sir.
can be written as 3 sigma I is equal to
I
1
equal
to
to
100
1.
I, right?
Yes, sir.
Right. So what is happening? Your 3 is going outside of the sigma, right? So
One
your
this
constant,
question explain, sir.
yeah,
E
I didn't get.
sigma L2 I is equals to L1 is F CF I was explain, sir.
Yeah. So basically what is happening is f of I is any function, okay? So instead of taking it as f of I, just take it like, what can you, like you have to take it, consider it as a function. So like what is happening is f of I. So here your f of I was basically I, right? So you can get a tough function also. You can get a tougher function also. So I'll just give you one like thing for sigma. We have sigma I is equal to 0, okay, to 100. You have 3i plus 2 raised to I. So now can you tell me what will you do? Like what
Sigma
is this thing? Hmm. Tell.
sigma
0 plus
100
No. Okay, just just expand the terms first. So it is
0,
0 plus 2 raised to 0. Okay, fine. Plus 1 plus, sorry, 3 plus 2 raised to 1, right? Plus
yes,
6 plus 2 raised to 3, right? 2 raised to 2. Like that, 300 plus 2 raised to 100. Fine. You can do this, right?
Yes,
yes, sir.
sir.
Right? This is what your terms are. So now what I am telling you, take the first terms first and your second terms later. So it is 0 plus 3 plus 6 plus so on till 300 plus, and take your second term. So it is 2 raised to 0 plus 2 raised to 1 plus 2 square plus so on 2 raised to 100. Can I do this? Can I write it like this?
Yes,
Yes,
sir.
Right? Because it is basically summation only. So now when you take your first sum, so it is basically 3 into 1 plus 2 plus so on till 100, right? And what is your second sum
Yes,
equal to?
sir.
so it
What
could
is
be
your
0
second
plus
sum?
1. So 0
Yeah.
plus 1 plus 2.
Yes, sir. 0 plus 1 plus 2,
Acha,
sir.
okay. So 0 plus 1 is like it is 0 only. So I started from 1. Okay, yeah, it is 0 plus, correct. But like 0 plus is 0 only. So that is why I just wrote it like 1 plus. So, okay, anyways, right? And it is 2 raised to 100, right?
Yes, sir. Yes,
I can write
sir.
this. So basically, how, like now you try to represent it. So it is 3 times sigma I is equal to 0 to 100 times I plus sigma I is equal to 0 to 100 2 raised to I. Right?
Yeah, sir.
So basically what has happened, your sigma has splitted. Your sigma has, like, it has splitted. Like, fine, you get it?
Yeah.
That thing that, okay, so your first term and your second term, your sigma has individually splitted. So that also you can write it, just in case if you didn't know. So it is sigma I is equal to L1 to L2. So it is uh, f of I plus g of I. Okay. So it will become sigma I is equal to L1 to L2 f of I plus sigma I is equal to L1 to L2 g of I. Fine. You get this, right?
Yes, sir.
Yes, sir.
So basically your sigma can get individually splitted. And in the first property, your constant was coming outside of your sigma, right?
Yes, sir.
Okay. So just one example I'll be giving you. So you have to calculate sigma uh, 2 raised to I minus 2I minus 1. Okay, and I is going from 1 to 100, right? So what will you do? What will you do in this situation? How can you write this thing?
Sigma I equal to 1 to 100
Sigma I is equal to 1 to 100,
2I
2 raised to
minus
I.
2 power I.
yeah, sir. 2 raised to I
Minus sigma
minus sigma I equal to 1 to 100 into I
times 2I,
minus
right?
Minus
sigma
I is equal to 1 to 100,
100.
1,
1.
right?
Yes, sir.
Right?
Yeah.
Right? So what is your first term? What is this first term equal to? It is basically 2 raised to 1 plus 2 square plus so on till 2 raised to 100, right?
Yes, sir.
Yes,
Yes,
sir.
What is your second term equal to? What is your second term? It is 2 plus 4 plus so on till 200, right?
Yes.
And what is your last term? Your last term is a bit tricky.
One.
If you
1 plus 2
1
is 100.
1 plus 2.
no, sir.
It
1
won't
plus
be
1
1
plus
plus 2.
1
Yes,
Correct.
till 100
Yes,
times.
correct.
till 100, sir.
Yes, it is 1 plus 1 plus 1 100 times. Correct. 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 So now you have got the essence of what your sigma is basically trying to represent, right?
Yes, sir.
And if you look clearly, if you look clearly, it is I is equal to 1 to 100, 2 raised to I, okay, minus 2 times sigma I is equal to 1 to 100 I. Fine, this thing can be written because your 2 can come outside, right? Minus sigma I is equal to 1 to 100 1.
One.
Fine. Fine. Everyone got it?
Sir.
Everyone got it, right?
Yes, sir.
Okay.
Yes,
Sir.
sir.
So basically your sigma is coming outside. Yeah, this one or this one, like this top part or this bottom part? Both? Your voice is not clear. Can you please repeat or can you please write in chat? So
1
basically
plus
the
1 plus is goes to 100.
yeah, because see, I just gave this as example in top also. So see what is happening. I am taking the sum of sigma I is equal to 1 to 100 n. Okay. So what is happening is inside I have a constant n and my variable that is being added is I. So it is like it is independent. It doesn't depend on I. So what will happen? It will just run this. Okay. N again because it is not dependent on value of I. So it will just treat it as a constant. Fine. So that is what will happen. And similarly, I had taught you this property that sigma gets splitted in plus and your constants come outside. Fine. So it is 2 raised to I minus 2 times sigma I minus sigma 1. So that is how you can do it. So can you find the sum of this thing? Can you help me find what will be the sum of this thing individually? Can anyone do it? No one.
We will try, sir.
So, like, it is just an basic GP, right? So you know how to calculate sum of GP.
Yeah, sir.
Okay. So tell me, what is the formula for sum of GP?
A
So what
into
is this?
1.
So first of all, just write this GP in expanded form for your better understanding. So it is basically 2 raised to 1 plus 2 square plus so on till 2 raised to 100, right?
Yeah, sir.
Yes.
Right?
Yes,
So
Yeah,
sir.
sir.
it is basically, what is your A? What is your A here?
2,
What is your
Sir.
2,
A?
sir.
Your
Two.
A is 2, correct. And what is your R, common ratio?
Two, sir.
Correct.
Sir.
So what is your sum? What is your sum?
A into 1 minus R
A
raised to
into
1 minus R
Ah,
raised to N by 1 minus R.
correct. So this thing can be basically written as 2 into 2 raised to n minus 1, right?
Sir, 2 raised to
Yes, sir.
100. Na?
Yes, and you can take as a, like, yeah, correct. There are 100 terms, so you can. So actually, I was just considering it to be any variable n. Fine. So this is your first sum of first sigma. Can you tell me what will be your sum of second sigma?
Sir, it will be
Uh,
2 into
2 into
50.
Sum of
5,000.
2 into.
5,050.
Don't go very fast. Go slow. No need to hurry up. So it is 2 into 1 plus 2 plus 3, so on till 100, right?
Yeah,
Right?
sir.
Yes.
So it is basically 2 into n plus 1 by 2. So it is 100 into 101 by 2. Fine.
Yes,
Yes,
sir.
sir.
So this thing is basically 10100. Fine.
Yeah, sir.
Okay, great. And what
Yes.
about this one? This one is really easy. What is this third sigma?
100,
It
sir.
is very
Sir.
easy. It is 100. Correct. It is 100. So basically, it is your, so your overall sum will be your first sigma minus your second sigma minus your third sigma. So this will be the overall sum of your expression. So this is your overall, this thing. Fine.
Yes.
Fine.
sir.
Okay. So moving ahead, I have just few more problems. So you need to find sigma k is equal to 1 to 100, 1 to 50. Okay. K is equal to 1 to 50. 2 plus 3 raised to k. Anyone who has not understood the question? There is no chance that you have not understood the question, right? Yeah. So can you tell me, anyone?
Sigma k equal to 1 to 50.
Correct. So first of all, we will take sigma. It will be sigma k is equal to 1 to 50 into 2, right?
Yeah,
Yes.
Plus
Yes.
sigma k is equal to 1 to 50 into 3 raised to k.
3
Yes.
raised.
So solve this thing separately and this thing separately, right? So this thing, can you tell me the first thing first? First things first. Your voice is not clear. Can you repeat?
so is it 100?
Correct. It is 100 because it is basically 2 plus 2 plus 2 50 times,
Yeah,
right?
Yes, sir. 100, sir.
So it is 100. First sigma is 100. And what about your second sigma? So it is 3 raised to 1, 3 square, so on till 3 raised to 50. Fine?
yeah, sir.
Yes.
Fine. So it is basically GP, right? So use that
Yeah,
GP formula. Use GP
A
formula.
equal to 3, R equal to.
So it
3,
is
sir.
A into R raised to n minus 1 by R minus 1, right?
Yes, sir.
Right? This is your second sigma. So the summation of these two
Yes, sir.
will be your final answer. So your final answer is basically 100 plus 3 by 2 into 3 raised to 50 minus 1. Okay.
Okay, sir.
Yes, sir.
Anyone? Any issue?
No, sir.
Sure.
Yes, sir.
See, you need to
Yes,
understand how your sigma operator is working. Okay, it is really important because what will happen now in JEE main and JEE advanced, they will not give you such series, very long series. They will not be giving you. They will give you in compressed form using this sigma operator. So you should know first of all how is your sigma operator working. Okay,
So
Yes, sir.
yeah,
Sir,
yeah.
can
What
you
happened?
explain some, sir? Sigma I
Which
upon
one? Sigma
one.
here.
Yes, sir. Yes,
So
sir.
see what is happening is it is 2 raised to I minus 2I minus 1, right?
Yes,
Okay.
sir.
So what will happen? I had taught you that your sigma gets splitted individually on each term. Fine. So it is
Yes, sir.
basically sigma. So your one sigma comes here. Okay. Your one sigma gets operated on 2 raised to I. Your other sigma is individually operated on 2I. And your third sigma comes here on 1. Fine.
sir. Why sigma also 2y?
Sorry.
First sigma also 2y.
No, it is 2 raised to I. 2 to the power
Okay.
of I. Okay. It is 2 to the power of I. Fine. So what will
Yes, sir.
happen? Your see this property of sigma operator. So your sigma gets splitted individually on each term. So if I'm giving you n terms, okay, sigma. If I'm giving you n terms, so let me take it as n terms as uh, a plus b plus c plus like that. I have n terms, okay. So what will happen? It will be sigma a plus sigma b plus sigma c like that. So it gets splitted individually on each term. Fine. This is
Yes,
the
sir.
property. So that is what is happening over there. You had three terms, 2 raised to I minus 2I minus 1. Okay, there were three terms. Arey yaar, what happened to this? So yeah, there were three terms total. 2 raised to I minus 2I minus 1. So it is getting splitted. So it is sigma 2 raised to I minus sigma 2I minus sigma 1. And we have evaluated the value of each of these sigma individually and then added it. Fine?
Yes, sir. Sir, why we are only
Okay.
adding two, sir, in second profit? Second one, sir.
In second one means this middle term.
Yes, sir. 2 plus 4 plus so on up to 200.
Yeah.
Up one, sir.
Yeah. So this and this are the same thing. See, one more property of sigma I had taught you that if a constant comes, so it will take out the constant. Okay. So it will take the constant outside. So here I had sigma of 2i, sigma of 2 times I. So this 2 is basically a constant, so it can come outside. So it will become 2 times sigma of I. Fine.
Yes,
Your
sir.
2 is coming outside of the bracket.
so
Right? That is what is happening. Yeah.
do you have any more properties of sigma other than
No,
these two?
only 2.
Okay.
Actually, these are not like if you look clearly, these are not properties also. I can't actually, I shouldn't call them properties also. If you clearly observe, it is just
Yeah, so
that you are taking out your like
constant
you have
terms.
something in common and you are just taking out your common terms. Fine, that is
Yes.
what is happening. Nothing else. If you look clearly, it is nothing new. It shouldn't ideally be called a property also. If you look clearly at it, what is happening is it is your sigma. Okay, so it is f of I plus g of I. So you are adding your f of I separately, you are adding g of I separately, and thus just doing it. So why we are doing it that way is because whenever you have something like this, okay, 2 raised to 3i plus 2 raised to I, so you can't be adding this and this like in together. It is not possible. You know the sum of 3i and you know the sum of 2 raised to I. You know the sum of AP and you know the sum of GP separately, but you don't know what happens when both of them are added. So that is why you are basically separating these two terms out and writing it in this way. Fine. So just if you just think clearly, you are not doing anything new, right? Everyone gets it, right? What I'm trying to say,
Yes, sir.
Yes.
that you are
Yes,
not
sir.
doing anything new. See, for example, you have a sum something like this. Okay, you have 3i plus 2 raised to I. So I have expanded it in this form. So now if you calculate the value of these individual terms and try to add it, it will be meaningless. You won't be able to do it. So what you did, you took the first terms. Okay, you took out the first terms first, and you added the first term. So it was a AP. Similarly, you took out the second terms, it was a GP. So now you can individually add the AP and individually add the GP and then sum it together. But you can't do AP and GP like one term AP and GP taking together. So like this was clearly not a series to you, right? So can you help me calculate what will be the value? It will be 1 plus this will be 5, right? Plus 6 plus 4 is 10, right? Like this.
Yes,
If
sir.
I give a series something like this to you, so this is not a like how will you add this thing? This is neither a GP nor an AP, and so you won't be able to sum this. So what we are doing is we are splitting it into two parts. One of which is AP and one of which is GP. That is what we are doing. Okay,
Okay,
fine.
sir.
Everyone got it now?
Yes,
Yes.
sir.
Yes, sir.
See, you can try it also. You can try it. You can substitute some more values if you want. So your first term is basically 1. Okay. Your second term will be 3 plus 2, that is 5. Your third term will be 6 plus 4, that is 10. Okay. Your fourth term will be, sorry, your third, I is equal to 3. So it will be 8 plus 9. So 8 plus 9 is 17,
17.
right? Like this, you will get your series. Now, if I ask any one of you to sum such a series, how can you do it? It is clearly not possible because this is neither AP nor GP.
Yes, sir.
How will you add this? So what I'm doing is you keep the first terms out separately, you keep the second terms out separately, add them individually, and then collab them together. Fine. So I just have similar a few more problems to for you as homework. So uh, so find sigma of I is equal to 1 to what year were you born in? 2009, right? You were born in, I guess, 2009. So I'll keep
2008.
it 2009.
8,
2008 you
sir.
were born. That's 8. Okay. No worries. 2008.
No, sir. Nine only.
Okay, okay. There was someone who was born in 9. So fine. It is this thing into into 7 by 9. Okay, 7 by 9. Just a second. So it is basically 70 by 81. Okay, into 10 raised to n minus 1. Okay, minus 7 by 81 into n. Oh, sorry, really sorry, really sorry. So my variable has changed to n. Fine, my variable has changed to n.
Yes, sir.
Everyone has understood this question, right? Anyone like actually there is no chance that you haven't understood. I am assuming. So just one
Sir,
more.
is it 7 power n or 70 n, sir? At last minus.
Sorry, it is
First question, sir.
7n by 81. 7n by
7n.
81.
Okay, sir.
7n by 81. Fine. So it is 70 by 81. Fine. Okay, great. Fine. So I guess that's it. And then after this, just keep one from my side also. So treat it as 2 into 3 raised to n plus, or I'll take one minus also, minus 3n plus 2. Okay, so yeah, that's it. So please do these two questions and come tomorrow and tell me the answer, okay? The first one is a little bit tougher because the first one requires little bit more algebra because you need to take out the common terms first and then evaluate. But believe me, like it is not tough. If you have genuinely done this one and this one, okay? If you have done this one and this one, so the first one shouldn't be very tough. And the second is easy only. So approach
So the
the second
second
question.
question 2 into 3 to the power n, sir.
It
2
is 2 into
points.
3 power n. 2 into 3
Okay.
power n minus 3n plus 2. Okay, fine. So that's it for today. Thank you. Have a nice day. I hope you have understood everything. And please do that one question also, that one S and T, and that A101 and B101, that one also. Okay, fine.
Okay, sir. Thank you, sir.
Thank you,
Okay,
sir.
thank you.
Thank you,
Okay,
sir.
thank you. I had actually told you that if you come, remember, if you remember everything I had taught you yesterday, so I had prepared Telugu song, but I will tell it tomorrow now.
అంటే అమలాపురం.
Yes, sir.
Acha? No, I had done B ante Butta Bomma.
బుట్టమమ్మా.
సూపర్ సార్.
Okay, okay, bro. Sure. Okay, good night.
గుడ్ నైట్ సార్.
Yes, students, you can join the next class. Kevin sir class, you can join Kevin sir class now.